Hey everyone, it's Mr. Oda. In today's video lesson, we are going to be talking about topic 4.5, global wind patterns. Now, in this topic, we're going to be explaining how environmental factors can result in atmospheric circulation. As for our essential knowledge, what you need to know for this topic is that the patterns of wind that we see are the result of solar radiation. And one thing that you probably know already is that the area that gets the most intense solar radiation is actually the equator. Now, a couple things about wind patterns. Uh, One thing you guys probably know already, you should know, is that the Earth rotates. And as it rotates, air circulates around. And because air gets heated and cooled in different ways, it changes the density and causes the convection or the flow of this air. Now, something that you guys have learned before is that hot air rises, and that is because warm, moist air is less dense than cold air. So the warm air will rise, it will carry with it water, and as it rises, it's going to get cooler as it goes up into the atmosphere. As it cools, it will sink down, but not before it releases the moisture in the form of rain. So hot air rises, cool air sinks, and then when it goes down, it will heat up and rise again, which creates a convection cell. Now, although the world doesn't work this way, if the Earth did not rotate, we would simply have one or two types of convection cells. We would have warm air rising at the equator, because that's the warmest part of the world. The warm air would rise, it would flow up to the North Pole and to the South Pole, and as it reached there, it would cool, sink, and then travel back down to the equator. However, this doesn't take into consideration the rotation of the Earth. And now, because of the rotation of the Earth, we get three different convection cells to the north and the south of the equator, and this is because of the Coriolis effect. Now, the name of these cells are the Hadley cell, which is from the equator to 30 degrees north and south. This is the same thing right here. This cell is the Hadley cell. You're noticing that the warm air rises, cools down as it goes to 30 degrees, and then flows back to the equator. The Ferrel cell is from 30 to 60 degrees north and south. And the polar cell is from 60 degrees to 90 degrees, the North Pole and the South Pole over here. This is just another way to view this, the Hadley cell, Ferrel, and polar cells. As you notice from here, the warm air rises. As it rises, though, it starts to cool down. It releases that moisture in the form of precipitation, rain, snow, things like that. As it travels, it loses that moisture. And when it falls here, this cold air is actually also dry. And this pattern repeats. It gets warmer, rises at 60 degrees north, rains down here, and then as it cools and falls, it is dry again. And same thing over here in the polar cell. This is just a GIF to show the different patterns of the wind. And one thing to note with this is because of the rotation of the Earth, not only does the air go up and down, but it also travels west and east, depending on where you are in the world. And this is shown in this image right here. You have the trade winds in the center of the world. You have the westerlies and the polar easterlies here. Now, one thing to keep in mind with this is because of the change in density and rainfall and stuff like that, you also get different biomes in different locations of the world. As I mentioned, warm air rises and carries water with it, and then as it cools, it will rain back down. This is why in the equator, you see all of your tropical areas, your rainforests and things like that, because there's so much rainfall. Now, as the rain falls, the cool air moves, it becomes dry, and when it descends, it's at 30 degrees north and south, and that's where you're going to find deserts, because the air has no more rain in it, has no more moisture. and so there's going to be nothing but desert there. Also, keep in mind that at 60 degrees south and 60 degrees north, there's going to be rainfall again because the warm air is going to rise. And we are going to be around this area. And as you remember, New York is a type of forest, a deciduous forest. So we do get a decent amount of rainfall here. And once you get to 90 degrees north and south, you're going to get desert areas again. But since they are Arctic, we call them tundras. And now this is just an overview of the wind patterns. Again, you have the three types of cells, the Hadley, Ferrel, and polar cells. And because of the rotation of the Earth, it also creates different trade winds, westerlies and easterlies, these prevailing winds over here. Now, to practice this concept, we have a couple of multiple choice questions. The first one, in the diagram shown, the red arrows represent warm, moist air. That warm air rises because of what? The Coriolis effect. It's pushed by the trade winds, it is more dense, or it is less dense. Hopefully you were able to get that. Warm air is less dense, so it rises up. Now, to make sure we know about the biome component of this. The first question, most of the Earth's deserts are at approximately 30 degrees latitude, north and south, because these latitudes are characterized by what? Generally warm ocean currents, predominantly low atmospheric pressure, descending dry air currents, or slow-moving jet streams. And for question 2, most deserts on Earth are located near the 30 degrees north and 30 degrees south latitudes because humidity is lower at 30 degrees. The best explanation for the lower humidity is that what? Hopefully you were able to remember that there is drier air falling down at 30 degrees north and south, and also that the warm air rises at the equator, cools, and sinks at 30 degrees latitude. Hopefully you were able to get a lot from this video lesson. If you have any questions, please ask them in class, and I will see you in the next lesson. Take care.